So hello everybody. Hi to all freedom lovers. My name is Matt Reschenberg. I'm the project manager of openqrm, and I will now talk about the openqrm management platform and how we achieve pluggable virtualization for modern data centers. So short to the agenda. Actually, how many people here at FOSDEM already know openqrm or have played with it a bit? Oh, a few. So I will still give a short or a basic overview about what openqrm is, what goals we are trying to achieve, and what you can do with it. Big part of the talk is about the pluggable architecture of openqrm, which allows to be very flexible with virtualization. That means plugging in virtualization technologies into your management framework for your data centers. We'll explain the virtualization layer which we implemented in openqrm, which is to unify different virtualization technologies. I will also give a few insights about why there is a great benefit of conforming different virtualization technologies. I will, after that, we have some more details about the already implemented virtualization plugins for openqrm, which is VMware, Xen, Linux vServer, and QEMU. And since this is a developer conference, and I want all you to contribute to the openqrm project, we'll also have a section in the talk later how to develop a virtualization plugin, what is needed inside the openqrm to fit in a new virtualization technology. And of course, there will be time for questions and hopefully also answers for you. So, first about openqrm. It's derived from a commercial project called QRM. This is developed by the Clusters company, and luckily I could convince them, or at least I was one source to make the whole project an open source project. It was quite some efforts which we had to do before going open source. It means cleaning up build system, the architecture, and so on. This happened at the end of 2005, and at the beginning of 2006 we are now an open source project. We used the MPL license, which is very similar to the GPL license. So from there on, there is an active development going on in the community, which mainly concentrates on writing additional plugins for openqrm. So, why plugins? First of all, I start a bit down here. When we rewrote or re-architectured openqrm before going open source, beginning 2006, we thought about that we need to have a pluggable architecture with a well-defined API to make it easier for developers to add new functionality or change existing functionality inside the openqrm server. And next to that, we want to keep the openqrm server itself at least we try to keep it very small and robust. So the benefit what we gain from this pluggable architecture we designed for openqrm is that we could parallelize our development. So we have a few developers sitting on the core and many other developers developing independent plugins and don't disturb each other with there's no code in so we can separate the code our developers are working on, basically, through this pluggable API. So basically, openqrm, what is a management system for data centers, and it's a deployment system. It means you can rapidly deploy a server to existing physical hardware or also virtual machines. there are monitoring tools being built in so that you also can monitor your servers and applications. And of course, also we thought about high availability in openqrm, which basically is a rapid redeployment if something fails. So the concept of openqrm is the separation of modules of the data center. That means on the one hand, the physical hardware, the bare metal, what we see from openqrm side as a kind of resource. This is CPU power, memory, disk space, and so on. On the other hand, we try to separate the operation system plus the applications from the physical hardware or virtual machine hardware. This is done mainly via net booting. So all computers managed by openqrm are normally net booting and managed via net booting. They can also start local, means start from the local disk if there's a local disk inside. The whole initialization of being able to manage a remote system over there in the data center is based on net booting. So openqrm therefore provides tools to transform an existing server to a server image from different types. So I come to that in a moment. First, when we have when we transform the server into an image, the image is basically just like with other virtualization technologies. It's basically a big file on some storage server. The advantages from having server images instead of local installed servers. First, I don't trust local hard disk. I recently came back from the LinuxConf Australia and found my hard disk of my workstation, where I still am using a hard disk, crashing at first boot up with a hardware failure. So it's kind of worse. So on the other hand, if you have a server image, it is located on a storage server, which normally has backup facilities, recovery facilities, and also snapshot features. Which means I can first I have the backup and restore in a central place where it should be on the storage server itself, and second I can use the cloning features, the snapshotting features of the storage server to just create new images of my existing server image. So basically what we tried to implement as a feature is integrating openqrm with modern storage server vendors or with open source storage server mechanisms like LVM, NFS on top of LVM or iSCSI on top of LVM, which basically gives the same flexibility as a NetApp filer, but it costs nothing. And with the interface from openqrm to the storage server, we can say, now I have an existing web server template, which I now need for my new 5 customers, and I can basically just create the configuration inside openqrm using the web server template base image, and let openqrm clone the server images on deployment. Means in the moment I want to start the server for customer 3, it will go to the storage server, clone, create a snapshot of the already existing known to work web server image, deploy it via net booting. That means bringing up a new server for my next customer will actually take just the time the system is going to boot, which is quite fast. I don't have to install anything. I don't have to touch or change things which I know that they are working. So having this, I call it appliance-based deployment method via net booting, we are using this also as a partition interface, as a virtual machine interface, to conform different virtualization technologies later. So first, this this was more or less about physical machines, but with the virtualization plugins existing for openqrm, this layer is also, this network booting layer is also used to first be able to very easily migrate from a physical machine to a virtual machine, and then from virtual machine type A to virtual machine type B. So let's coming back to the goals and concepts. So the first is separation between different modules in the data center. The second is we abstract those modules with a term called virtual environments. This is your new web server you need for the next customer. Inside this virtual environment configuration, you tell openqrm which kernel I want to boot, which boot image basically, which root file system I want to boot. This is the big server image laying on a storage server somewhere. And how I want to start this new service. It means service level agreements, it's about high availability, it's about should this whole thing, the web service, should it be run on a cluster, how many nodes the cluster need, how many CPU speed the application need or memory. All this goes into the virtual environment configuration, and the virtual environment later or basically represents the service that I want to deploy in openqrm. So I will then have a web server customer A virtual environment, which I later can start and stop via single mouse clicks via the web interface of openqrm. So when it comes to virtualization, this is only then, with this abstraction, only a select box inside your virtual environment configuration, where the administrator of the box selects, oh, today this server should run on a physical machine, or tomorrow it should run inside a VMware virtual machine, or the next day it should run into a Linux vServer partition, and after that maybe at the weekend I need it on a physical box again. So this is all about transparent resource planning, which we integrated into the virtual environment abstraction. Okay, I talked about a huge selection of plugins, pluggable architecture, and there are already a huge selection, about 20 plugins available for openqrm, which adds different features to the base server. Examples for that is a Nagios plugin for enhanced monitoring. We have integrated Linux CUE as a plugin, which gives you an automatic installation as a next form of a deployment method. We have the virtualization plugins, which we will talk about in a few minutes in more detail. So we also integrated LVM storage, NFS on top of LVM, and iSCSI on top of LVM, so that users can use this instead of buying a NetApp filer, for example. Last but not least, we have support for different operation systems. Also, non-Linux operation systems can be deployed with openqrm. Examples for that is FreeBSD, Solaris, and surprisingly also Windows. We can deploy Windows machines with that. So this is the basic overview of openqrm, and this is needed to understand better the way how we integrated this virtualization layer in openqrm. Let's start a bit at the beginning. We heard some different speakers here today talking about virtualization, and so we have not a single technology which everybody have to use, but we have a great choice of different virtualization technologies. I'm always try to group them into this three virtualization methods, which is full virtualization, power virtualization, and kind of isolation or container-based virtualization. So I will not go into detail anymore. I expect that everybody from you guys know what is full virtualization, power virtualization, container means. So we are not going that deep into that. But there is the need for the system administrator to choose to select a virtualization technology or virtualization vendor for his needs. So what are the needs? The needs are basically the application needs. So what we have lots of different application, and some are more happy with full virtualization, some are happy with power virtualization, and others are prefer lightweight or container-based virtualization. A good example is if I would virtualize an Oracle database, I would think about like Xen or VMware, something like that. If I'm a web hoster and I want to deploy 1,000 or hundreds of Apache web service, root service for renting to my customers, I would definitely go with solutions like Linux vServer or OpenVZ, which are much more lightweight, so I can start many more machines on a single virtualization host than on Xen or VMware. So basically, this means as a system administrator, I do not have to choose one virtualization technology and stick with it, but I have to support more than one, and basically at least 3 to make all my applications and all my users happy. So 3 different virtualization technologies and the requirement to also manage the physical systems. Quite a lot, quite a goal. So what we tried, or what we implemented, is we unified the deployment layer via this net booting, which then also is used to conform the different types of virtualization technologies. When I have a Xen virtual machine, moving this to an ASX host, to a VMware host, it's quite some manual work. You have to adapt the configuration file. You have to also transfer the disk image from one server to another, and then to make from the Xen block device disk image, make a VMDK out of it. So lots of manual things to do with for the system administrator. With the openqrm deployment method via net booting, we don't need to do anything. We don't need to change anything on a server image to move it from a physical machine to a virtual machine. It's just, we just configure a different resource type, not physical machine, not bare metal, but a virtual machine from type Xen or VMware inside the virtual environment profile. And the next time my virtual environment starts up, it will use a Xen virtual machine instead of a physical box. So this all gives us a transparent support for migrating from physical resources to virtual partition. And also, then later, if I put my application on a Xen virtual machine and I would just want to try it in Linux vServer or in QEMU, we can do this on the fly without any changes on the server image. So the server image, by known to work web server template, cloned on deployment time, it will never change. So let me give some more details to this cloning on deployment time feature. Sure, we all have templates for our applications and servers, and this works quite well. Still, for each customer or for each resulting virtual appliance or virtual machine, I need to change minor things or major things on the server image itself. It's a clone. It has some static entries for etc host maybe, or it has a HTTP configuration file which should be adapted for each user or for each resulting server which I want to bring up. We also have an option in openqrm to do this fully automatically via the Puppet plugin. Puppet, I'm not sure how many people know Puppet already. Quite a lot. Great. It's known to be the next generation of CF engine. It's an automatic configuration management utility which we integrated in openqrm as an additional plugin, so you can just enable and disable it as you like or as you need. And what you will gain from it is, after openqrm automatically cloned your web server image and started it up on a free available machine, the configuration, for example, of the HTTP conf file can be adapted automatically via the Puppet plugin. So I just have to cut and paste HTTP conf receipt into my Puppet configuration, also via the openqrm user interface. And the next time I start the server, it will automatically adapt or get a new HTTP configuration file before actually starting the web service on the server. Okay, so we also can automate this. So why using openqrm for managing virtualization? We have lots of applications or tools for virtualization nowadays, which are for creating partitions, starting, stopping them. There are GUI applications, there are web applications for that. But why using openqrm? Because openqrm is not only a GUI for a single virtualization technology, like you have for Xen, you have XenMan or Xen, some GUI utilities which are more or less concentrating just on Xen. For VMware, you have the commercial options, the ESX, VMware Center and stuff like that. For Linux vServer, there's a web GUI available. Why not using that? Because what we try with openqrm is to combine all those utilities, or to combine useful utilities to create a single management console. I don't want to use loosely tools, one for this, one for that, this for the next virtualization technology, but I would like to have one utility which helps me to manage my complete data center. And this is what openqrm tries to achieve. So it's not only a GUI for a single virtualization technology, but it also cares about the deployment of your virtualization host. We always excuse me. We're always speaking about bringing up new virtual machines, starting them, stopping them, managing them, and so on. But actually, we are never really much talking about how to install a virtualization host or how to deploy. I would more or less say deploy, because I don't want to install it. What I want is a virtualization host server image, which I can, the same as the web server, clone on deployment time. So if I need a new one, I just say start. So with openqrm, openqrm cares also about the deployment of your Xen host or deployment of your Linux vServer virtualization host or QEMU host. And it brings all Xen utilities within the Xen plugin. So you basically then can use any of your existing server images without having the need to have Xen installed on this server image, but just use this, start it, and in the virtual environment configuration, tell it's a Xen virtual host. So what will happen? The server image will be cloned on deploy. It will be booted on a free machine. It will boot the hypervisor, of course, not the Linux kernel, but the hypervisor, which boots the DOM-0 kernel, excuse me. And it will automatically install Xen on your server image during boot up. So after that, basically you just say, I need a new Xen virtualization host. It's based on my image XYZ. It should be a Xen host. It's a checkbox which you just enable. And you say start, and you will have a virtualization host up and running without any installation, without needing to install Xen or configure anything on the server image. So the next thing is, when about virtualization, normally people start with one server or with two virtualization hosts, and then the needs from the users are going up, and then I need a third one, a fifth one, and so on. With openqrm, we can we support out of the box clusters of shared virtualization host. What does that mean? We can let our Xen virtualization host. It's a virtual environment inside openqrm. It's a configurable virtual environment. We can make this cluster. We can select. We can configure with how many nodes it should start up, with minimum, maximum nodes, and then all the nodes all the servers in the cluster will use the same server image root file system. So basically, this helps a lot for updates and security patches, because I don't have to maintain like 50 server images, but just one. The second, what it does is, with the virtual environment configuration, minimum and maximum numbers of nodes, I can make the whole thing scaling up and down automatically. That means the cluster will start up with minimum nodes, let's say 5, and we have maximum nodes 15. And when there is load on the cluster, generated by the virtual machines, for example, openqrm will automatically add new physical servers to this virtualization cluster, single system image cluster, so that enables the system administrator to migrate virtual machines from one virtualization host to another within this single system image cluster. So the thing what I learned from especially Profos EU, this is a conference basically a month ago, focusing on virtualization, is that people want to have something like a cloud computing. So they have a cloud of virtualization hosts where physical systems are being added and removed automatically according to the load of the cluster. So the cluster scales up automatically, up and down. And what they also want is that the virtual machines inside this cluster are being migrated automatically to the hosts inside the cluster which are less loaded. So it's an automatic load balancing of physical machines which are scaling up and down inside the cluster. And within this cluster of physical machines, we have lots of virtual machines which are then also being able to move from one virtualization host to another. So what we implemented for now is we can have the automatic cluster of shared hosts which scales up and down. The next thing on the roadmap is to actually find a good implementation or a good mechanism to decide when a virtual machine should move from one virtualization host to another. So it's a kind of load balancing we have to implement, and it just will be an additional plugin in openqrm. So the partition management. So we just talked about how to bring up a virtualization host, a VMware or Xen or Linux vServer or QEMU host with openqrm, basically fully automatically through this server imaging and appliance-based deployment. So now, how are the partitions or the virtual machines are being managed in openqrm? With its partition layer, with its partition abstraction layer, openqrm maps the commands, for example, reboot, shutdown, the administrative commands, to the actions on the virtualization host. It means openqrm, when you reboot a server or one of your virtual environments, which can be run on a physical system or on a virtual machine, openqrm knows that it is running on a physical machine or on a virtual machine. And if it's running on a virtual machine, it will not run send and reboot to the virtual machine, but a reboot to the virtual machine host, which then runs, for example, the virtualization command for this specific technology. For VMware, we have VMware CMD shutdown or a reboot. With Xen, we put this on top of the Xen API using XM reboot. So openqrm automatically maps the commands which are going to my server, either executes them on the physical servers like the real reboot command. Or if it's a partition, if it's a virtual machine, it goes to the virtual machine host and reboots the virtual machine on behalf of the host. The administration itself, because of this abstraction layer, this net booting abstraction layer, it's just like physical servers. They appear in openqrm. You create some partitions, some new partitions. They will appear in openqrm as free available resources, which then can be used to deploy your server images on. So the virtual machines can very easily move from one virtualization type to another, because the server image itself, it's disconnected from the virtualization technology. So we don't have to move a VMDK to a Xen block device or extract the root file system of a VMDK to be able to run it on Linux vServer. But we just have server images there and resources over there. And resources can be physical or they can be virtual. openqrm just managed the rest. Okay. So I'm now telling a bit about the virtualization plugins, the details about the virtualization plugins which we already implemented. Basically it's Xen, Linux vServer, QEMU plus the KVM extension, and VMware, of course. With Xen, the Xen plugin gives you a bunch of features, which I won't read them for you on the slide. But of course you have start, stop, pause, unpause. We recently added live migration support for Xen, which is the first step to this cloud computing stuff where things are balancing and scaling up automatically. We also added a Xen console in the openqrm user interface. That means you can, inside your openqrm, inside a web browser, with the openqrm user interface, you can directly access the console of your virtual machines. Yeah. I should say something about our deployment methods. So what I said was that the whole flexibility in openqrm is a result of net booting servers or virtual machines. When they are net booted, we have different deployment methods. The common deployment method is through NFS root. I know some people don't like NFS so much. For the root file system, it's working quite well. We also have implemented first standard iSCSI root. Means you can deploy, you can have your server images on an iSCSI LAN, which will be connected at boot up, which is very cool because on the iSCSI storage, you can have a regular file system like Extended 3 or a RiserFS, which gives the great advantages that not everything what the system reads and writes from its root file system goes immediately through the wire like it is with NFS. But with Extended 3, there's a lot of journaling and caching inside the system's RAM. So the system actually will read and write to the network when it has time for it.
Are the root file systems read-only?
No.
So do you manage conflicts from different host names?
Yes, we manage them. This can be done via the Puppet plugin for an automatic configuration. When you create this single system image cluster, you are currently limited to NFS root. We have also mechanisms to have private directories within each node of the single system image cluster. It means you can define private areas and areas within private areas which are shared again via configuration file. With iSCSI, of course, we have a non-cluster file system normally on top of it, like a Single 3 or RISE-IFS, as I just mentioned. You can have the single system image-based deployment also with iSCSI root, but you have to use a cluster file system like OCFS2. I did tests with it, which were very promising. You could also use GFS for that. Yeah. So these are different deployment methods: NFS root, iSCSI root. We also have local disk dump. That means local deployment. We can grab an image from an existing server's hard disk, transfer it to a storage server location, and then use this image to dump it back to another server's hard disk. And this all happens again through net booting. But after the image is being dumped to the hard disk again, the node will just reboot local. So we also have local deployment. With the virtualization plugins, the Xen plugin supports NFS and iSCSI storage deployment. We don't really focus on local hard disks within virtual machines, because these are basically just files which should be not on the virtualization host, but somewhere on a modern storage server which automatically cares about backing up and creating snapshots and so on. So this is a screenshot. Everybody likes screenshots of the openqrm user interface, especially the Xen configuration. This is we have different methods what plugins can provide for openqrm. This is the web page integration. So we have the plugin brings a new web page which allows you to manage, configure, and set up your virtual machines. This is the Xen console which we implemented. I just told it you can access now the virtual machines console from within the openqrm user interface. What we try to manage is what we try with openqrm is to really not reinvent the wheel. So if there's some project which is known to work and common to use for system administrators, we try to integrate this into openqrm and use openqrm as a glue to make different components cooperate together and to let them cooperate with the main management framework. So this opens up a lot for automatism, which you don't have when you just use loosely connected tools. Sorry? I think I cannot make it really bigger on the fly. I'm not sure. But yeah, come to me after the talk. I will show you. Okay. So next is the QEMU plugin. We have a list of features. It also supports NFS and iSCSI deployment. It does not require any special boot image because the QEMU has very less requirements on the actual virtualization host. It only needs a TUN device, TUN tab device to run. We recently added also support for KQEMU, which is an accelerator module provided by QEMU itself, and also for KVM. That means you can also run QEMU in full virtualization mode with openqrm. So then we have the Linux vServer plugin, very lightweight container-based virtualization. For now, it supports only NFS storage. It means your server root file systems should be on an NFS server. Why is this so? Because with Linux vServer, it's a virtualization type with just one running operation system, and we don't really have the option now. What we could do is we could connect root file systems on iSCSI targets via the iSCSI initiator. The thing is that this would require to have the iSCSI tools and the initiator module running inside, available inside the Linux vServer host kernel, which is still kind of tricky. I tested it and it does not work stable yet. But I'm in contact with the Linux vServer guys a bit to see what we can do there. So last but not least, we also have the VMware plugin, which is currently maintained and provided by the clusters company. It's the professional services company behind the openqrm. So the only difference between the VMware plugin and the other virtualization plugins is that the VMware plugin does not care about deployment of your virtualization host, which means GSX or VMware server or ESX. Why not? We found out that we want to support VMware server, which is basically the GSX, and we want also to support ESX. And to make ESX net booting, it's not supported by VMware itself, as far as I know. So we also based this on the VMware API, and the VMware plugin supports the NFS and iSCSI deployment type plus local deployment. So within VMware, you can have your local disk if you want. I recommend not to use local disk at all. So basically, this is a common setup from a workmate from me. He's providing also professional services for openqrm and doing installations and maintenance for customers. This is a web hosting setup he's using. It's one openqrm server with running the server image is running on NFS, and everything is booted via PXE. And he has just one standby virtualization host. So in case one of the DOM 0, A, B, or C, or D crashes, openqrm will automatically notice that and rapidly redeploy the DOM 0 standby and move the partitions from server 1 to the standby server, basically. Okay, so this is a bit more advanced setup. Yeah, basically it's a big RAID system, a storage server managed directly interfaced with openqrm, which provides lots of Xen virtualization hosts, which are then used for the different departments or for the customer. It's research, IT. There are a huge number of regular clients, 350 clients, using the virtual machines inside this data center setup. Okay. So, since this is a developer conference, I also would like to give some overview about what needs to be done to implement a new virtualization type for openqrm. So in general, there are just two classes to implement in Java. It's quite easy. For example, now the Xen plugin, the code for the plugin is using the namespace in the line above, below the namespace. What needs to be done is to implement Xen partition bridge. This is for every virtualization type. You need to implement the generic partition bridge of openqrm with the specific features and differences for the virtualization type. It means the Xen partition bridge basically maps the administrative command of openqrm to the virtual machine commands via the XM utility. And it then runs the virtual machine commands on behalf of the virtualization host the virtual machine is running on. So we also thought about putting in these third-party libraries like libvirt, which tries to achieve the same goals as openqrm. At the point we started with that, libvirt was not really usable except for a Xen virtualization type. So now it's a bit more improving, and we will think about reconsider it for the next implementation. The second class what you need to implement is the Xen MAC address provider. This basically generates random and unique MAC addresses for your new partitions, because when you create a new partition, you also need to create a new virtual network interface. This is basically the only unique part. So this is the it's pseudocode, so don't compile it. This is the implementation of the Xen partition bridge. It, as I mentioned, it extends the base partitioning abstraction layer inside openqrm. This is the example of the start command or start from off command. It finds the virtualization host for the virtual machine, and then run the start partition command on the node with the resource attached. So the start partition command, I have to get on a bit faster, don't have so much time anymore. The start partition command is basically, it runs a script on the virtualization host, which then with some command line options, which are then doing the job, basically creating a new XM configuration file, running XM configuration file start, and to bring up the partition. So the other class what we need to implement was the Xen MAC address provider. This is basically how MAC addresses are generated in openqrm from a template. So each virtualization type has its MAC address base, which is then being used to generate MAC addresses from. So as I mentioned, this is pseudocode cut and pasted from our source. It may not compile exactly like this, but this is basically how MAC addresses are created. So, summary and conclusion. We have an open architectured, fully pluggable data center management system with openqrm. We made it fully pluggable to let you easily contribute to it by writing new plugins for it. There's a well-defined plugin API. openqrm itself conforms to different virtualization technologies via via net booting and via the generic partition layer inside the base server. What we benefit from is completely transparent resource management, physical boxes, virtual machines on one side, server images, my root file systems and applications on the other side, and I just can deploy on whatever I want, either physical or virtual machines. Yeah, and as I said, the plugin development is made very easy for you developers. You just have to implement 2 classes to get a new virtualization type into openqrm, and that's it. So the future roadmap, we will of course focus even more on virtualization. Next on the list of plugins we want to create is OpenVZ, VirtualBox, and Virtuoso. And what we also think about is to give more options for the user for each virtualization technology inside the plugin configuration page. So, and I would like to announce a major sub-project in the openqrm community. We had lots of feedbacks from the community on this helped us to create a focus and evaluate the current state of openqrm, and we definitely want to port it to PHP now. We want to go away from the Java, from the big Java engine. We want to port it to PHP. And this development just started and is being very active recently. So, your code and contribution is of course welcome. If you are good with PHP or so, or if you are interested in virtualization and have some free time and fun to contribute, just contact me and we will of course find some interesting task for you. Here how you find the openqrm project on the internet. It's a project on SourceForge, and my email address if you want to contact me directly. And it's now time for your questions. Any questions? Yep.
How do you reboot physical machines?
Sorry?
How do you reboot physical machines?
The question is, how do openqrm reboot physical machines, right? We have, since everything is deployed through netboot, we have an automatic mechanism which starts 2 little daemons on each server managed by openqrm. One is a small monitoring daemon which sequentially sends the monitoring statistics to from this system to the openqrm server, and the other is a remote execution daemon which is based on an IP address authentication, so that the openqrm server can run administrative commands on all managed servers. So basically, we send a reboot command via this execution daemon, and the system itself will run reboot. Yes?
Are these agents that you also detect that the physical machine is down and this triggers the high availability?
Yes. This is one method when the monitoring statistics are not being sent in a certain interval. openqrm will get to know that this system is down. Of course, for enhanced monitoring system and application monitoring, we recommend the Nagios plugin, which is basically doing the same but on a much finer level. And the thing is that the Nagios errors, I'm out of time, I have to stop. With the Nagios errors are brought to the openqrm engine, which then can react to that. So, okay, if you have any more questions, just come to me in front of the door, and I will be happy to answer them. And many thanks for your attention.